we're going to look at how to compare these two patterns. All right, now I've used the same one so that we have the algebraic expression, which is easier for us to look at. And we're going to compare these using a scatter plot, which is simply just a graph. Okay, now when we look at our graph, all right, we come down to our graph paper, all right, and you can see I've got some grids there, all right. Now, your term number, all right, will always be along your horizontal axis, all right. So it will always be along your horizontal line, the line going across the page. Okay, that's your term number. All right, so I'm going to label that now. Term. Oh, sorry, that doesn't really look like a R. Term number. Okay, and that's always going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and we put these on the lines, not in the space. Okay, on the line. Makes sense? Okay. All right. Now, we have to construct our y-axis. Okay. Now, this is going to be our value. Okay. Always our value. Okay. Now, where these two lines meet is always 0. Okay. And I'm going to give my values of 2, 4, 6, 8, 10. Sorry, my pen. Oh, sorry, that should be 11. Should be 13. Okay? All right. So my graph is prepared. All right. Now I have to go back up and look at my patterns. Okay? So I know that this one is simply start at 2, get to 6, get to 10. Okay? And this one is going to be start at 5, go to 9, go to 13. Okay? All right, now I'm going to plot these points. All right, your term number for the first pattern has a value of 2, so I'm going to use a red. All right, so go down to my graph. All right, my first term has a value of 2, so I'm going to plot that point right there. Okay, my next has a value of 6 and then 10, so I'm going to plot that as well. So my second term has a value of 6, and then my third term has a value of 10, so I can see that. Okay, then I'm going to simply connect the lines. Okay, and I'm going to use, let's use red for this one. Okay, all right. So I'm going to use red, and I'm going to connect those lines together, and so on. All right, and I can predict any value along that line. So I can say that my fourth term, okay, my fourth term, if I go up from my fourth, all right, it connects the line there. It has a value of 13. Okay, all right. Okay, so my fourth term, all right, has a value of 13. Okay, and now if I'm given a value, I can say, okay, well, what's the value of 8? What would the value, if you have given a value 8, what's the term number? Okay, well, I'll do, I don't know, I'll do 14. Let's for say. Okay, or maybe even 15, whatever. Okay, so if I go up to the next value, okay, and let's say, well, I can find the 14. All right, if I go, well, we'll do the 12. Okay, so if I take this and I go across the 12, Okay, and then I go down from the 12, I can see that my value of 12 is going to be somewhere between my 3 and 4, okay, for this particular pattern. All right, so that's how you use the scatter plot in order to determine different things. Okay, makes sense? Okay, so that's my first line, and that algebraic expression was my, okay, that was my 4n minus 2. Okay, now if I were to continue that line, all right, if I continue that line along that same trend, okay, I'll notice that it's going to hit my 0 below that line. Does that make sense? Okay, so that means that it's going to be, my 0 term is going to be in the negatives. Okay, and you notice the line doesn't start right at 0. We discovered that not all lines start at 0. They work their way through, all right, okay, each point. They can be anywhere. They can start somewhere on the x, they can start somewhere on the y, and we're going to see that with our next one. All right, the next part, what I have to do is I have to go up and look at my other pattern. So my first term is 5, 9, 13. All right, so I'm going to use blue for this, and I'm going to go, my first term is a value of 5, so it's going to be there. And then my next term has a value of 9, which is going to be there. Okay, and then my third term has a value of 13, which is going to be there. Okay, and if I do the exact same thing, okay, I connect these dots. I'm going to make this one green, okay, to represent the little green dot. Okay, so I'm going to make that green, and I can see that if I connect these dots right through a nice straight line, okay, all right, that it follows a different path. Okay, and I can continue this, and I should, wherever this line, oops, wherever this line meets, okay, the y-axis, that's going to be your 0 term. Okay, so we have this one meets at the 2, right there. All right, so you can see that our 0 term is 2, and if we go back up to our, oh, it should be 1, sorry, 0 term, I've got the line off a little bit. Okay, should be at the 1, not the 2. Teachers make mistakes too. We make that. Okay, that's why it's important to have your line at the 0 term, because it'll tell you where it starts. All right, and so you get the right angle. There we go, that's right. Okay, so a little mistake on my part, but okay, so we can see that our 0 term, okay, starts there. Okay, makes sense? All right, so, and we know that these are similar in the fact that they skip by 4 each time, so they should be a parallel line. And if we change this color, okay, we know that this line is 4n, all right, 4, 4n plus 2. Okay, so you can see the difference. Okay, so going back over it, step 1, okay, table of values. Okay, step 2, okay, and I kind of did it in reverse, construct your graph. Term number is always on the horizontal. Okay, so you can see that you're constructing the graph. Okay, once you construct the graph and you filled out your table of values, you simply plot the points on the graph. Okay, term number along the bottoms, and you plot the points, and then you connect the dots, the points, with a straight line, making sure that your lines connect at least to one of the axes. Okay, so you can see that the green line connects to the y-axis, or the term value, and the red line connects to the x-axis. Okay, you want to make sure that you go through all of those. Okay, and then you're done. Okay, now we use this to compare different lines. Obviously, these lines follow the same trend, just one start is slightly higher, but they're going to increase by the same amount. They're parallel lines, they'll never meet. Okay, and that'll have more applications later on in grade 9. Okay, so that is absolutely everything that you're going to need to know how to do from start to finish in order to be able to do well on the test. Some things that you have to, some terms that you have to remember. Okay, some terms that you have to remember, all right, is going to be the algebraic expression. Algebraic expression. Okay, and that's simply the, okay, that would simply be, all right, the pattern rule, the 4n plus 2 or 4n minus 2 in the example that I've showed you. Okay, the next thing is you might see nth term. Okay, this just simply means the pattern rule. Okay, nth term or pattern rule. Okay, and this is the same. All of these are exactly the same. You might also see general rule. Okay, the general pattern rule or general rule is the pattern rule. These are all the exact same terms. Okay, last thing. You might be asked to find something like this. All right, 2n plus 3 equals, all right, 2n plus 3 equals, let's say 5. Okay, so how would you figure that one out? Well, you simply are given a blank. 2 times what plus 3 will equal 5. All right, and we know, okay, so we need to add 2 plus 3 is 5. So I need to make this 2. So this can be a 1. So 2 times 1, all right, equals 2 times 1 equals 2 plus 3 equals 5. So therefore, the first term would give you a value of 5 in this particular instance. You might be doing something like that, okay? But in most cases, you don't have to. Other questions that you might be given, okay, is something like this, all right? X, I'll draw that a little bit better, okay? Something like this. X equals 3, and then you have to solve for 3x plus 3. Okay, so then what you're going to do is you're going to simply substitute in for x. 3 in brackets. All right, so this means 3 times 3 plus 3, all right, is going to equal a value of 3 times 3 is 9 plus 3 is 12. Okay, now this is kind of funny in that it's 3 times 3, all right, plus 3 gives you the same value as 4 times 3. Interesting. All right, in this particular pattern. So in this case, you have to substitute in for the variable because you're given. This just basically means that the third term, all right, the third term, what's the value of the third term is basically what it means, okay? So what's the value of the third term? Well, we figured it out. We put in for the value of the third term. We put in the term number into the x, because x is just a placeholder. We know that 3 with the number in brackets is 3 times 3. Okay, it's multiplication there. And then we simply multiply out. 3 times 3 is 9, plus 3 is 12. Okay? All right? Now, I made a mistake, all right? And if my math didn't work out, I wouldn't know what to do. All right? So I'm going to show you, showing all of your steps. All right? So I should have ended up with 9 plus 3. All right, and then equals 12. Okay, I should show this step just in case. Okay, and that is absolutely everything that you will see on the test from start to finish. Okay, so from the first video to this video, make sure that you know what to do and pose some questions. If you want to make a couple of diagrams or get your parents to draw out a couple of diagrams and you find the pattern and then you work on it together, go for it. I urge you to do that, but that is everything that you will need to know for this particular test, which is patterning and sequencing and relating that to algebraic understandings. All right, good luck.